Hello again, everyone. Welcome to another day of Advent of Code. Here today is very cold. It's actually snowed overnight. I wonder if I can show you. We've got cat, and hopefully you can see outside. Decent covering of snow. My kid's out playing with, doing some snowball fights and stuff. I actually got a good night's sleep last night, so hopefully we will be good for today. And it's the weekend, and I've had coffee, and I'm feeling good. So let's see what we have today. Day 10. Cathode Ray Tube. You avoid the ropes, plunge into the river, and swim to shore. The elves yell something about meeting back up with them upriver, but the river is too loud to tell exactly what they're saying. They finish crossing the bridge and disappear from view. Hey Gray, how's it going? Situations like this must be why the elves prioritize getting the communication system on your handheld device working. Today's puzzle's fantastic fun. Okay, I'm looking forward to it. You pull it out of your pack, but the amount of water slowly draining from a big crack in its screen tells you it probably won't be much immediate use. Yeah, cracking. So I basically drop my phone all the time. Either I'll have it in like a loose pocket, or I'll put it down somewhere absent-mindedly and accidentally knock it off something. So my screen, I get a screen protector for it, and then I immediately crack the screen protector. So my phone just always has cracks in it. Oh well. Hey Vagrant, how's it going? Unless, that is, you can design a replacement for the device's video system. It appears to be some kind of cathode ray tube screen and simple CPU, which are both driven by a precise clock circuit. The clock circuit ticks at a constant rate. Each tick is called a cycle. Ooh, are we doing like a CPU simulation? Start by figuring out the signal being sent by the CPU. The CPU has a single register, X, which starts with the value 1. It supports only 2 instructions, add X, V, which takes 2 cycles to complete. After 2 cycles, the X register is increased by the value V. V can be negative. No op takes 1 cycle to complete. It has no other effect. Okay. The CPU uses these instructions in a program, your puzzle input, to somehow tell the screen what to draw. Consider the following small program. Execution of the program as follows. At the start of the first cycle, the no-op instruction begins execution. During the first cycle, X is 1. After the first cycle, the no-op instruction finishes execution, doing nothing. At the start of the second cycle, the add X3 instruction begins execution. During the second cycle, X is still 1. During the third cycle, X is still 1. After the third cycle, add X3 instruction finishes execution, setting X to 4. Okay. I'm glad I took the time to read over this, because I was thinking that these would like overlap. That, you know, this would be that there's some kind of like pipeline going where this instruction is issued but only finishes on the second cycle. But no, the entire CPU waits until this execution is complete. Okay. During the third cycle, X is still 1. I just read that. At the start of the fourth cycle, the add X minus 5 instruction begins execution. Then during the fifth cycle, it's still going, and at the end of the cycle, that instruction finishes. Okay. Maybe you can learn something by looking at the value of the X register throughout execution. For now, consider the signal strength, cycle number, multiplied by the value of the X register. During the 20th cycle, and every 40 cycles after that. Okay. Some weird instruction pipelining CPU would make for a good problem. Yeah, I think it would. Maybe we'll see one later. For example, we've got a larger problem. Okay, wow, that's long. The interesting signal lengths. The interesting signal strengths can be determined as follows. During the 20th cycle, register X has the value 21. So the signal strength is 20 times 21 equals 420. Okay, that's that during is the thing to keep in mind. It could very easily get like an error Okay, so you find the signal strength during the 20th, 60th, 100th, 140th, 180th, and 220th cycles. What's the sum of these 6 signal strengths? Okay. So this is what, like, we program something to... It would be nice if we can, like, get a range representing all of the cycles. Representing the value during every cycle, and then just drop the first 19 and then stride for 40. How could we get a nice range for that? I think we can use coroutines for this puzzle. I'm going to try and use coroutines, see if we can get that working. Okay, where's my terminal? Oh, I'm using the wrong version of Visual Studio. Just give me 1 second. That was like a internal preview of Visual Studio, which I use for testing out features which are up and coming, and I don't particularly want to accidentally show off some Visual Studio feature which has not been released yet, so I will not be doing that. Hey, Amber System, thanks for joining. Yeah, no VS leaks in this stream, hopefully. I'm glad I caught it. To be fair, I think that, like, the internal build I have is old enough that I wouldn't be showing off anything. Anyway, new day, new day, new day. Day 10. Alright. So I think what we're going to do is... we'll make a... I'm going to try and think how we can use coroutines for this, because I think that it maps nicely onto the problem. What we can do is something like, we're going to make a simulator which takes our input, and this is going to give us back a range representing the values of the X register at every cycle. And then what we're going to do is, what was it? Multiply the... What's the signal strength? The signal strength is the cycle number multiplied by the value of the X register. And the cycles are 1 based or 0 based. During the first cycle, so I'm guessing that's 1. Alright, so we could do something like std views zip. No, enumerate. Well, if we do enumerate, so it enumerates a view which will give us back the index, but it will be off by 1. So we could do a zip with an iota view, or we could just do a... You know, let's just do an enumerate, and then we'll do a +1 to all our indices. Type to enumerate, so this will give us a pair of the cycle index and the what's it called, the value of the register, and then we can do transform. Hey Rock Brother, how's it going? Index and X register, and just return a pair of I + 1 X just to correct that off by 1 error. And then what we want to do is multiply these together. We could just do that in here. Ooh, actually, I can show off something kind of cool. If I get TL functional curry, what I can do is to multiply together these values. So I in theory, like, want to use std multiplies, right? Std multiplies takes 2 instruction, it takes 2 values and multiplies them together, but it takes them as regular arguments, and we're passing it a pair or a tuple. So I have this thing called TL uncurry, which you can pass a function object or something, which takes multiple arguments, and this changes it into a function which takes those arguments from a tuple or a pair. That's kind of nice. And thanks to follow SciHack. Nice name. And then we want to sum all of those. So that's our signal strengths is that, and then we do std cout of TL sum of signal strengths. You know, strengths is the longest single syllable word in the English language, I believe. We need TL, where's sum, fold.hpp. Okay, so now we just need to write our simulator. So I want to use coroutines for this, so what I'm going to do is I do have my own implementation of a generator type. So I'm going to grab that. It's in VZ package, so this should just work. And my simulator is going to return a TL generator. Not generate, I want generator. I have to wait until VC package is done. Generator, there we go, generator.hpp. So how coroutines work in C++ 20 is you customize them based on the return type. So what a coroutine is, basically. A coroutine is a function which, so we've got a regular subroutine, right? You can have a bunch of code which is doing stuff, and then at some point you return, right? This could have multiple return statements, but essentially the subroutine is entered at some point and it's exited at some point. A coroutine, however, can be suspended. So you can have something like some code, and then a co-yield, and then some more code. And what this will do is run this code, and then it will yield back this value to the caller, suspend the coroutine, and then it can be resumed later. I can't pipe into TLSum. I don't have the support for that. I could add it, but yeah, right now I have to do this. And how this works is basically co-yield doesn't have built-in meaning. The meaning of it is taken from the return type of the coroutine. I just have 13 messages on Signal. I'm just going to make sure that nothing horrible has gone wrong. Nothing horrible has gone wrong. Okay. So this is taken by, I say, TL generator, and we're going to generate integers. And this is going to take a std iStream reference. Hey, Ernesto DPC, how's it going? And what this does is it lets us handle all of the state of our simulator in a function and not have to like keep track of it between calls or use a closure object or anything like that. But we can just yield back values to the caller, and everything should just work in theory. Let's see how we go. Thanks to follow. Too easy for me, bro. Have you tried this puzzle? Is it too easy for you? So, let's see. What's our state going to be? We're gonna be we're gonna have we're gonna do TL get lines to get all of our lines in a range. Thanks to subscription, Gray. So our line's going to be TL views get lines of input, and we only ever need to go down this list, so we don't need to put it into a vector. But we do want to keep track of our position in this list because we're actually we'll see how we go. Anyway, we're gonna have so some of these take 2 cycles, right? So we're gonna have our main loop, which is gonna go, say, while we have not reached the end. So let's say current is gonna be std ranges begin of our lines. So while current is not std ranges end of our lines, then we're going to keep on processing commands. So our command is going to be either a no-op or an add x. So we can do a split using our handy split helper. Which will give us back strings split on a delimiter like space. So now if command 0 equals no op, then we're going to do no op, and otherwise we're going to do, I'll put in an if else here just so that the code's easier to read. Otherwise, if it's add x, is that correct? Yes. Add x, then we're going to do our add instruction. So now this is going to be delayed by 1 cycle essentially. So maybe what we can do is just have a std optional. Oops. Whoops. Which is going to be our to add, which is going to start off as still std null opt. So if we get an add command, then we're going to say to add equals command 1, and this should be command 0. Okay, so if we get to a new cycle and we already have something in our to add, so we can do if we have something to add, then we're going to add that to our X register, which begins at 1, I think I recall. Then we're going to do X plus equals to add, and then clear to add. Hey, ZT Freak. Okay, and then continue, or, you know, I don't really like using continues. It just makes the code a little bit harder to follow. We're making a simple CPU simulator, and I'm using coroutines for it. Okay, so semicolon. So if we have something to add, then we're going to add it and then clear what we had to add. Otherwise, we're going to read a command from the from current, and then we're going to do ++ current here. So now where do we put our yield back to our caller? So our yield was during the instruction, during the cycle, which I believe is at the start. So if we, at the beginning, we co-yield So let's think over our logic. We need to string to int here. So let's think over our logic. What we're doing is we're starting off at the beginning of our input. We are parsing our command. If it's a no-op, then we just do nothing and we move over to the next line. If it's an addx, then we don't do anything this cycle. We add, because addx instructions take 2 cycles to complete, we're adding our, we're converting our argument to an integer and caching it in this optional. And then the next cycle, we are actually doing the addition. And then moving on to the next line. Okay, so this should give us back essentially a range representing all of our the x value at every cycle. And then we wanted to do like a drop and then a stride, didn't we? So the signal strength during the 20th, 60th, 40th, 20th, 60th, 100th, 40th. So we do std views drop the first 19 values to get the 20th value, and then std views stride with a stride of 40 to take every 40th value from the 20th and then sum them. Alright, I'm going to compile this. Enumerate is not. If this works, I think it's quite a nice solution, I think. Oh, not std views, enumerate. Enumerate is, I think enumerate is going to make C++ 23. I can't quite remember where that ended up. Ooh. That's not what I hoped for. Saying I can't deduce template arguments for basic iterator. Does enumerate have to be? There's some constraints that I'm getting failure for. Are you not missing brackets on the enumerate? I don't think I am, because this I think that's supposed to just work as it is, just, yeah, like there's no call to that. Let's have a think about this. Because if this solution, if I can get the solution to work, I'll be pretty pleased with it. I like using coroutines for this kind of thing because, you know, we've got all of the state, which we just don't have to worry about if we're using coroutines. Should transform be taking a pair as input instead of 2 separate parameters? Yes, 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 it should. Unless I uncurry it. But I don't think that's the problem. Like, because this enumerate call is completely failing for some reason. Is TL generator not valid for some reason? You know, so one thing is with ranges, you tend to get better error messages if you, instead of using the std views or the TL views, you use TL enumerate view and instantiate it directly like that, just because of how concepts work. You can often get a better compiler error. Anyways, still saying, okay. So, failed to specialize, function template, basic iterator, could not deduce template argument for basic iterator from our enumerate view cursor. Okay. Let's so this was in which function is this trying to instantiate? While compiling begin. So it's here trying to instantiate basic iterator for cursor false. So let's pass cursor false as explicit template argument, and that should give us a better compiler error. There we go, the associated constraints are not satisfied. That's what I'm looking for. So this is actually an improvement we've made in Visual Studio, well, in MSVC recently. It used to be that if you got a constraint failure, it would just say, hey, some template constraint failed, good luck. Whereas now we actually give you a much better error. So it says like, the associated constraints are not satisfied because all of these concepts evaluated to false, which should really not happen. And that means that our cursor for my generate implementation has some bug in it, maybe. I haven't touched this generator in a while, and things have moved around a lot in ranges and coroutines, so it may well be that there's something in my my iterator for my generator type now which is not valid. So my options are try to debug my generator type or use some generator type from somewhere else, or check if my generator type is maybe out of date on VC package. That could be a possibility. Like 15 months ago, I haven't touched this in a while. For now, let's just copy paste this and see if that makes any difference. Whoops, I just tried to run the wrong thing. Okay, same error, so that's not the problem. There's probably some issue with my my generator implementation. Let's see if we can find a CPP coro, a thing which has a generator type. Yeah, there's a lot of code. I think Contan had a ranges-based coroutine implementation. Ranges next. Let's see if we can use his, yeah, he's got a generator type, which doesn't have any other dependencies, it doesn't look like. Let's steal this for now. Are you returning anything at the end of your coroutine? Could that cause problems? No. I mean, it might be that I'm doing something wrong in here, but let's as a just to see if we're doing anything obviously wrong, let's try a different generator implementation. Okay. Just try and compile that. Symbol cannot be defined within namespace stood. Okay, well, we're still getting an error here, which is not my favorite. That's not my favorite thing that has ever happened. I'd really like to get this coroutine thing to work. Hey, negative nonsense. It's like I've got a solution I'm pretty happy with, but we're hitting some issues in getting my my coroutine implementation to work nicely with my enumerate view. Like, this should work for single pass iterators, which coroutine generators are. They're single pass because you can't like go back in a coroutine, but that shouldn't matter because we're simply like incrementing current and position and then returning a reference to those. So I don't see why this is not working. So all of these constraints failed, like copyable for enumerate view of TL generator of cursor evaluated to false. So why would copyable fail for that if does this need a copy constructor? Can't type. No. Is there something to do with the iterator type of our generator? Oh, the iterators to generators are non-copyable because coroutine handles point to a unique resource. So how are we supposed to use these for ranges stuff? There's a standards paper for for generators. We're going down a bit of a rabbit hole for this puzzle, but I'm fine with it. Just a generator. Just make sure we've got the most recent version. Okay. So does this have a copy constructor? Generator meow with quack. So generator has an iterator type. Where's generator iterator? Generator iterator is move only. Okay. That kind of sucks. Like, is there some other way I can still use move only iterator with all of these ranges? So generator is a move only view which models input range and has move only iterators. This is because the coroutine state is unique resource. Hey Spaceberry, how's it going? And because the iterators are move only, we can't have hold one of them in an enumerate view, which is a real problem. Unless can I? Because we could just collapse all of this into a vector, right? But that kind of ruins the entire point of having our coroutine in the first place, because we want to be able to treat this as a nice range without having to dump it into memory. So to get this working, we could do to stit vector and then just pipe to TL views, enumerate, and pipe our vector to that. No, semicolon. Oops. And this could work, but I'm not pleased about it. Maybe we'll get the puzzle working with this and then see how we go from there. I'm getting 0, which is not... Well, that's because I didn't write any input into the file. Okay, so let's take this sample input. And give this a run. Debug assertion failed. Oh, we tried to access an empty optional. Whoops. Yes, we did. Optional has an overload for assignment from its stored value. Okay, so our what's in our vec? Size 240. 1, 1, 16, 16, 5, 11, 11. Okay, it doesn't walk through all of this example. Let's just see if we get the right answer, and if not, we can step through the smaller example. So this gave us 13140. 13140. Okay, that's correct. One 1820. That's the right answer. Okay, so let's do part 2, and then maybe we'll see if we can get that coroutine thing working. Seems like the X register controls the horizontal position of a sprite. Thanks for the follow, Mad Flash. Specifically, the sprite is 3 pixels wide, and the X register sets the horizontal position of the middle of the sprite. In this system, there is no such thing as a vertical position. If the sprite's horizontal position puts its pixels where the CRT is currently drawing, then those pixels will be drawn. You count the pixels on the CRT, 40 wide and 6 high. The CRT screen draws the top row of pixels left to right, then the bottom of the row below that, and so on. The leftmost pixel is in each row is position 0, the rightmost pixel is 39. Like the CPU, the CRT is tied closely to the clock circuit. CRT draws a single pixel during each cycle, representing each pixel of the screen as a hash. Here are the cycles during which the first and last pixel in each row are drawn. By carefully timing the CPU instructions and the CRT drawing operations, you should be able to determine whether the sprite is visible the instant each pixel is drawn. If the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn, the screen produces a lit pixel, otherwise it leaves the pixel dark. The first few pixels from the larger example above are drawn as follows. So sprite position starts off at the left, and then during cycle 1 draws a lit pixel in position 0. During cycle 2 it draws a pixel in position 1, which is also lit, and then it moves the sprite. Then it begins. Okay, I can't see where this is going. Okay, allowing the program to run completion causes the output. It causes the CRT to produce the following image. This is very cool. I like this. Okay, so basically what we're doing. Oh, we'll just run it with our regular input. Let's just copy this for now. Okay. So this is going to be all of our signal strengths for wait, we don't care about signal strengths anymore, right? This is all about the value of the X register. Yeah. Okay, so we can get rid of all of this. Basically, these are our X values for every cycle. And now we're going to loop over all of our X values, and we're also going to keep track of which pixel we're currently drawing, and if that X value is either on the pixel we're drawing, or to the left or to the right of it. Then we're going to draw a hash, otherwise we're going to draw a dot, and we're going to output a new line every 40 characters. That seems about right. Okay, so I'm going to take our I and our X from enumerate our X values, and if our X value minus our I, yes, I do want to rename this to part 2, thank you. If std_abs of X minus I is less than 2, then we're gonna see out where's std_abs again? CMath. Don't know why that's failing to compile. We'll see what compiler error we get. We're gonna output a hash. Otherwise, we're gonna output dot. So you know what we can just do. Just cout output hash. Otherwise, a dot. It's easier to read if you use space characters instead of dots. I will take that advice, thank you. And then if I mod 40 is 0, then we're also going to output a new line. Let's compile this. Ambiguous. Weird. Oh, ABS is only a float thing for some reason. Okay. Well, we can just do if distance is greater than -2 and distance is less than 2. Fine. Well, that's a lot of spaces, so probably not what we're looking for. So, right, our I has to be mod 40 as well, at the very least. So let's use the test input and see where we're going wrong. Okay, so what we should be doing is the sprite starts off at 1. Let me just make sure we don't have any off by 1 errors here. Anyway, so sprite starts off there. you need to subtract 1 from I before the modulo because the pixels are, yeah, that seems about right to me. I minus 1 mod 40. Something like that. No, because we actually, I'm using enumerate, which is giving me it 0 based. Okay, so we start off with x is 1, and our pixel, does pixel start at 1 as well? I know we're drawing the 0th one, so our distance should be 1, and it's going on here. Distance is greater than -2 and distance is less than 2, but this is false and distance is 1, and this is, I'm doing like something very obviously wrong with this expression here. Because this is outputting a space and it should be outputting a hash. What's the obvious thing I'm doing wrong here? Is it literally precedence? Not like in the number of brackets we're getting here. Distance is greater than -2. Is distance unsigned? Type is distance. Unsigned. Let's just make this long and make this a long. Integral promotion strikes again. False. Oh, that's just because I hadn't set. There we go. That's it. Integral promotion rules. Let's just run this and see what happens. Yeah, that looks mostly right. I think I've got I output a new line at the wrong point, but other than that, looks kind of legit. Yeah. Ugh. Yeah. Implicit casts are just the worst. They can just catch you out like that when you're not expecting it. What's my logic for my new line is wrong. Does this need to be 39? That looks better. Yes, that looks correct. So ABS should work now because distance isn't unsigned anymore. ABS of x minus pixel is less than 2. Just compile now with brackets. Yep. Insidious cast going on here. Yes, I'm Cybrand. I do stream sometimes. Usually, this is the second year I've done Advent of Code streaming. It's fun. Thanks for the follow. Okay, so we should just give this our regular input and this should work. In theory. This is a fun puzzle. I like this one. And then I would like to get that coroutine thing to work. Those look like capital letters to me. Can I pin this to the top? No. Okay. EPJB. EPJB. RKAH. RKAH. That's the right answer. Yay. Let's have a quick look if we can get this working. So the thing that I don't like that I'm doing now is, so I have this cool coroutine implementation of the simulator, right? And it takes in my input, converts it to lines, iterates over them, keeps track of all of the state, and then just co-yields the value at the start of each cycle. But iterators to coroutines are, iterators to generators are non-copyable, which causes problems because as soon as you try and give that to something like enumerate, then everything breaks. So I ended up having to stick everything into a vector. And I don't like it. It's not nice. And I'm wondering if there's a way to wrap is there a way to wrap my generator such that I don't have to do the converting to a vector? Maybe there's like a ref view or something. Is that what I need? Do I need to so this doesn't work because associated constraints are not satisfied. Let's do enumerate view because we get better errors. So yeah, this is where we're getting our constructing our basic iterator. Does not work because, let me get rid of, I'll leave it for now. So what if I do pipe to views std views ref, or is it std ref view? No, they're not std ref view. Std ranges ref view. Anyone in the audience know how to deal with move only iterators in ranges? So it's not that. Basically what I want is such that my iterators are proxy references, essentially. And I don't know if there's an adapter to do that or what its name is. So range adapters. Ref view, owning view. What are the iterators of this like? Is this what I want? Can't deduce template arguments. No, I don't think that's what I want. Like, SID refu seems like it's the kind of thing that I want. It wraps a reference to that range. No, this just like returns the iterators. Let me have a look in range v3 and see if there's anything in here which looks like what we want. If anyone else has any ideas, feel free to shout them out. We want something which returns like std ref of your iterators. Let's see anything. Let's have a look at the documentation. The range v3 documentation is not the best, but so shared view. What's a shared view? Ranges, views. This is not helpful. I'm not seeing anything. That shared view might be something. Just shared view do. No, it just stores a shared pointer to the range, but then gives you back just the regular iterators. I think I might have to ask some ranges experts how this is supposed to be done. Like, we could try writing something very basic. Like if we just steal this. And add something called, I don't know, move only. Do I need to std move the generator? The generator's already a like in this case it was already an R value. Like I can give it a shot here. Yeah, constraint's not satisfied. Like, search and replace. And then this is going to, oh, let me take all of the hash includes from here as well. I'll need those. We're doing like experimental ranges stuff now. Someone must have thought about this. Like there must be a way to do this. Otherwise, the generator as ranges is just like kind of useless. Okay. So here, let's get rid of this, get rid of this, and we need to, so we can't copy the iterator, so we're gonna have a reference to current, and then this is just this. We don't need position. We don't need position. We don't need position. Read is just gonna dereference current. That's gonna do that. That's gonna do that. That's gonna do that. Okay, and when we to begin, when we create our cursor, we're going to cache the iterator in our range itself. Or I guess we could just move it into here. But is this just gonna... I don't think this is gonna work, because I have all of this like basic iterator machinery which implements a bunch of the nonsense for me, but I think requires the iterator type to be copyable. So I don't think it's gonna work. Well, you know, I'm gonna talk to some of my friends who are ranges experts and see what they suggest for making this actually usable, and maybe tomorrow I'll have an answer. Why does the generator need to be copied? The iterator gets copied underneath some of the machinery which I have. Maybe it's because my machinery is wrong, like this basic iterator type stores a cursor somewhere. There's so much stuff in here, like this is a lot of code. I can't remember where this thing actually gets started. But yeah, like at some point in all of this machinery, iterators get copied, because most of the time iterators are copyable, right? But yes, I will try and have an answer for tomorrow, and maybe we can come back and get this working. But for now, I'm gonna head off. Thanks everyone for joining. See you all around.